Hey guys, welcome back. Hey, so Monday we were introducing the topic of finding the surface area of some three-dimensional objects, and in particular, we were looking at this shape called a prism. Now, prisms don't have to have a rectangle on the top and bottom; they just have to have the same shape. But the common one we were studying last time was this one, and the notion is the same regardless of what the base shape is. Now, remember, there's whatever we call the base shape is whatever shape appears at two ends of the prism. So in this case, there's like if this were a cardboard box, there's the top of the box, which I'm going to highlight again right here. And then there's an exact copy of that, just that you can't see it in this picture, but it's hidden down here. Okay, so there's that. And then there's a back corner here. Okay, but the idea was, or we tried to point out and realize that if I want the total surface area, there's two things about this base shape that end up being used. One of them is the area of that shape occurs twice. It's once up here, and I'm just going to remember we labeled that with a capital B, and there's another one of those right down there. So the total surface area of this shape always involves finding the area of that base shape and multiplying it by 2 because there's two of those. Now, in this shape, the other four rectangles all have the same one common length. That's the height of the prism here. And if I were to add up the other dimensions of those four rectangles, that's essentially finding the perimeter of the base shape. And so the idea there is to get all of that area at once. We just need to take the perimeter P of the base shape and multiply that whole perimeter times the height H. And then that gives us the area of all of these vertical rectangles combined. And if I add that to the two base shapes, that gives me the total surface area. So again, the reminder is that three things are: P was the perimeter of the base, in other words, the distance around it. H is the height. And the capital B, that was the area of the base. I should have put of the base here too. Remember, this general idea works no matter if the base shape is a rectangle like it is here, if it's a square, or if it's a triangle, or any shape really. Now, in fact, today to transition from the prism to the cylinder, we want to point out that really the same principles can be used. The only main difference this time is all cylinders have circles as the base shape. So there's a circle at the bottom of this one too. Okay. So when it says, so if I want to use the same notion, instead of the term perimeter of the base, you could replace that with the circumference of the circle. Okay. And so I'm going to try and fill that in as we go here. And instead of perimeter, we're going to think of the perimeter as the perimeter of that circle. And for circles, we call that the circumference. The height is the distance between the circles. And then for the B, it's the area of the base shape, but in all cylinders at the circle. Okay, so there's something special about that too. So really, in this one, what we used to call the perimeter of the base is now the circumference of the circle. So common things that we've learned before is that for a circle, the circumference is 2 pi times the radius, and the area of a circle is pi r squared. So what we end up doing is taking this quantity and replacing it where the perimeter of the base used to go. Okay, so 2 pi r, and then for the perimeter, and then for the area of the base, pi r squared. because that's how you find the area of every circle. Okay, so our final version of this is 2 pi r h plus 2 pi r squared. The next slide has this written without the parentheses there. Okay, so let's highlight it. If you took time to save the reference sheet I gave you guys on Monday, here is here it is on it's this one, the reference sheet 2. The surface area for a cylinder is 2 pi r times h. Remember, that's like the circumference part times the height, and then 2 of the circles. Each of the circles has an area of pi r squared. So I'll write that at the beginning of all of the 2 examples today, and we'll use it to calculate the surface areas. Okay, so here we go. The 2 problems we have are, in this cylinder, we notice that the radius is 4 inches and that the height is 6 inches. And it's asking for the surface area in terms of pi. So let's recall our formula. It was 2 pi r h plus 2 pi r squared. And let's just make a note of the quantities we're going to need. We need to know what the radius is, which is 4, and the height is given to be 6. And so we're just going to fill it in now. It's 2 times pi times the radius 4 times the height 6. And on this side, it's 2 times pi times the radius squared, which is 4 squared. Okay, so you may or may not need a calculator to do this next bit of multiplying. Now, I'm going to multiply everything together in each of the 2 parts except for pi. Okay, so again, we're not going to use 3.14 or pi or anything. It says leave the answer in terms of pi, which means the pi symbol will stay in the answer. So in the first part, everything except for pi would mean 2 is multiplying by 4, and that would make 8, and then 8 multiplying by 6 is 48. So this first part leaves us with 48 pi. Okay, and then the second part is to take 2 and multiply it by the quantity 4 squared. Now you might want to just think about that first. 4 squared is 4 times 4, which is 16. So everything but pi would leave 2 times 16, which is 32 pi. Now this time we're adding 2 terms that both have pi. So if I add 32 plus 48, that's going to leave us with 80. So 80 pi is our final answer. And since this is area and the units are inches, this will be 80 pi square inches. And notice we're just going to leave that. And I believe in MathXL, you'll do the same thing. You will not multiply 80 times 3.14. Just leave it as 80 pi. Okay, let's do one more. And this time there's no picture. It just does provide all the information, though. It says a cylinder has a height of 9 and a radius of 10. We could even draw a rough diagram of that if you like. Let's draw a cylinder. And the height was 9, so that's kind of coming right over there. And the radius is 10. That's from the center of the circle out to the edge. Okay. And let's recall our formula. Surface area was 2 pi r h plus 2 pi r squared. And the radius was 10. And the height was 9. Okay, so we'll fill it in. 2 pi times 10 times 9, and then 2 times pi, and the radius is 10, so 10 squared. Okay, I encourage you to pause the video right here and try and do the bit of math yourself before I work it out as well. Okay, so multiplying everything except for pi in the first term is going to be, let's actually do 9 times 10 first and get 90. And then since 9 times 2 is 18, 90 times 2 would be 180 times pi. And then out here we've got 10 squared, 10 times 10, which is 100, And then 100 times 2 would be 200. And then times pi. Now that means to add the final two parts together is going to leave us with 380 pi. Now this time the units were centimeters, so this is going to be square centimeters. Hope this helps you today, guys. We'll see you back here on Friday.